Okay, welcome viewers. So in the last video lecture, we saw that how to solve homogeneous recurrence relation of order 3. So we continue our discussion from there only. Okay, so I want to solve two examples of the similar type. So suppose I have this question: an plus 6 times an minus 1 plus 11 times an minus 2 plus 6 times an minus 3 equal to 0. Okay, so what is its order? Here order is n minus 3. Okay, so it is what? It is 3. So what is its characteristic equation? So the characteristic equation is alpha cube plus 6 alpha square plus 11 alpha plus 6 equal to 0. Okay, now again, as I discussed in the previous video lecture, okay, similarly we try to find the factors of this last number. Okay, so what are the factors of this last number, or you can say what are the divisors of this last number? These are plus minus 1, plus minus 2, okay, plus minus 3, and plus minus 6. Okay, but here you see that here all the signs they are positive. Okay, so no positive number can satisfy this equation. Okay, so as no positive number can satisfy this equation, it means that out of these 8, okay, we have only 4 options left to check that which one is the root of this equation. Okay, so I check it for alpha equal to minus 1. If I set alpha value equal to minus 1 here, it becomes minus 1 cube, 6 into minus 1 square, 11 into minus 1 plus 6 equal to 0. Okay, so minus 1 cube is what? It is minus 1 plus 6 minus 11 plus 6 equal to 0. So it is what? 12 minus 12 equal to 0. So what it is? It is 0 equal to 0. Okay, so it means that here this number alpha equal to minus 1 satisfied this equation. Okay, now we use here hit and trial method, right? The coefficient of alpha cube, which is 1, coefficient of alpha square, which is 6, coefficient of alpha, which is 11, and then constant term, which is 6. Okay, now on this side you write that number which satisfied your equation. Now this time minus 1 satisfied our equation, so write here minus 1. Now write this first number as such below this line. Okay, now multiply this number with this number. Okay, 1 into minus 1 is what? Minus 1. So write down it below the second term. Okay, so add these two numbers. 6 minus 1 is what? It is 5. Now multiply this number with this number. Okay, so 1 into minus 5 is what? It is minus 5. 11 minus 5 is 6. So multiply this with this. Okay, 6 into minus 1 is what? It is minus 6. So here what you get? You get here 0. Okay, now as minus 1 is the root of this equation. Okay, so it means that alpha plus 1 is the factor of this equation. Okay, and the remaining polynomial, it should be a polynomial of degree 2. So these are the coefficients of polynomial of degree 2. So alpha square 5 alpha plus 6 equal to 0. So it is alpha plus 1 alpha square plus 3 alpha plus 2 alpha plus 6 equal to 0. So alpha plus 1 into, take alpha common from here, alpha into alpha plus 3, take 2 common from here into alpha plus 3 equal to 0. Okay, so what do you get here? Alpha plus 1, alpha plus 2, and alpha plus 3 equal to 0. Okay, so what are the roots? Roots are minus 1, minus 2, and minus 3. So for these roots, how can we write the solution? C1 minus 1 raised to the power n, C2 minus 2 raised to the power n, C3 minus 3 raised to the power n. Okay, so this is the solution of this problem. I hope you people have understood it. If you have not understood it, then watch this video once again. Okay, now next question. An plus 3 plus 3 times an plus 1, sorry, an plus 2 plus 3 times an plus 1 plus an equal to 0. Okay, so what is the order here? order here is n plus 3 minus n. Okay. So what it is? It is 3. Okay. So therefore characteristic equation is alpha cube plus 3 alpha square plus 3 alpha plus 1. Okay. Now when I see this term and this term, so this last term can be written as 1 cube. Okay. So alpha cube 3 alpha square plus 3 alpha plus this one can be written as 1 cube. Okay. So here this first term is the cube of some number, this term is also the cube of some number. So whenever this happens, then you check this identity always. Okay. That here you may get this type of thing, a plus b whole cube, this is equal to a cube plus 3a square b plus 3ab square plus b cube. Okay. So I check that here this is a cube plus b cube plus 3a square b. Okay, because I can introduce 1 here, and this is 3ab square. Okay. So this can be written as alpha plus 1 whole cube equal to 0. So what are the values of alpha? As here the power is 3, so it is minus 1, minus 1 and minus 1. So here we get repeated roots. So the solution for this is C1 plus C2n plus C3, C3 n square, okay, bracket close, minus 1 raised to the power n. Okay. So this is the answer of this problem. We in the next video lecture we will learn that how to solve the problems when we have complex roots. Okay. So thank you very much students for watching this video.